Hello, so this is my summary of the SUVAT equations, and these are equations that can be used to describe the motion of something that is accelerating with constant acceleration. So basically something like a ball being dropped if we ignore air resistance, or maybe it could be used to calculate the motion of a car that's accelerating from one velocity to another velocity. And any time that you know that the acceleration is constant, you can apply these equations. I won't write anything out, but you should know that u is always going to be the initial velocity, v the final velocity, a the acceleration, s the displacement, and t the time it all took to happen. Now, these are pretty easy to use, but you do need to make sure that you can rearrange them, and there are a few hints and tips that you need. Now, one of the things that you might need to know is what the acceleration's equal to. And, well, one thing that you should think about is if the question's referring to something falling, they are basically telling you to use the acceleration to equal little g, which equals for us minus 9.81 meters per second squared. Now the minus becomes important, and there are instances where you can ignore it, but I think life's a lot easier if you just get used to always putting the minus sign in. And in fact there are some questions where you will lose marks if you don't sort of do this. And really this links back to the previous video about motion graphs, where I said that the convention is that positive is upwards. So you know that gravity always accelerates you downwards, so it's in the negative direction, hence a minus sign. The other thing that often comes up in questions is that it says that something starts at rest. And that's giving you a little bit of information. It's telling you that u, your initial velocity, equals 0. Now this is quite handy because one of these expressions, s equals ut plus half at squared, often with that u set to 0, you lose this whole first term and you just get s equals half at squared, which is a lot easier to solve, especially if you're trying to find out what the time was equal to, say, because at the moment it's a quadratic equation and you'd have to use your quadratic formula to solve it. If we lose that term, it becomes dead simple. The other thing is, this is only for constant acceleration. So you're looking for things that are generally moving in straight lines or have been thrown, or projectiles. As soon as you've got something like a roller coaster, which seems to come for some reason up in questions all the time, you can't use these equations. You have to use energy equations. And then the final thing is that we do make an assumption when we're using these, and the assumption that we use, which is basically why the acceleration is constant, is that air resistance is either non-existent, or probably a better thing to say is negligible. And now I'm worried that I can't spell it. Negligible, that will do. Negligible. And that's obviously not true, because things have terminal velocity, and we'll look at that later. So if you jump off a bridge into nice sort of soft water, you'll find that you don't keep accelerating at a constant rate, because the faster you go, the greater the air resistance gets, and your acceleration decreases until you go at a constant velocity. But we will ignore that in any of the questions that use SUVAT equations. So what's not important right now is where they come from. You could look this up in a book or come and speak to me about that. It's actually in the smart board that I'll attach onto the little website, But really what they're doing is they're finding things out about graphs. So in this one here, s equals ut plus half at squared, it's effectively, if you plotted a velocity time graph, it's basically a formula that lets you work out the area underneath the graph. And for like v equals u plus at, it's basically a formula that lets you work out the gradient of the graph, of a displacement time graph. And that's all there is to it, really. They are quite easy, and questions involving these are quite easy as long as you're systematic. The big problem comes from choosing the appropriate question. So I'm just going to pause this, write out a question, and I'll give you an example of how you would approach it. Okay, so here's my question. I've got a car, quite proud of my car, that's accelerated from 10 meters per second to 30 meters per second, and it took 1,000 meters to do that. Now, the danger with the SUVAT problems is that some students just decide they like one particular equation and try and apply that all the time. But you just have to have an open mind. So the way to do that is I would always write down what the question gives you. So I would literally write down SUVAT. And what I want to know here is what the acceleration is. So let's put a question mark next to the acceleration. That's what the question is. And then let's see what else we've got. We've got s. Well, that is, it took 1,000 meters. So I'm going to write 1,000 here. The initial velocity, 10 meters per second, and the final velocity, 30 meters per second. It doesn't mention the time. So I would just maybe put a cross through the time. So what you do now is you ignore the numbers, you look at what you've got. We've got S, U, V and A. Now after you've done a few of these, you'll quite quickly realise that there's only one SUVAT equation that doesn't have the time in. So that's letting us know that we need to use v squared equals u squared plus 2as. Now at GCSE you would be encouraged to put the numbers in the equation and then solve it. At A level, because it gets a bit more complex later on, we wouldn't recommend that. What I would do is rearrange this and make the acceleration the subject of the formula. So A is going to equal, well, v squared minus u squared, v squared minus u squared, all over, I want A on its own, divide both sides by 2 and by s, v squared minus u squared over 2s. Put your numbers in and solve it. And that's it. That's all there is to SUVAT. I haven't got a calculator with me, so I'm not going to do that. You could try this with all the other questions, and actually I have posted a video as well with some worked answers to the questions that were given out in class. So thanks a lot and goodbye.